Okay, now we're going to take up with where we left off in the last video. So we have example 6.5 down the bottom of page 69 of your workbook. We have power rule of exponents is what we're going to take a look at. So we're going to see this 2 cubed raised to the power of 2. So if we were to calculate that out, we would have inside the parentheses, we would have 8, and then that would be squared, and then we would have 64. But what if we used our rule to say that we have a base of 2 cubed, right? So really what this means is 2 cubed is my base times itself. I have 2 factors of 2 cubed. Then I can use my base to add the exponent rule, right? My power rule. And then we're going to get 2 to the 6th, which will equal 64. So those are equivalent things that work. So now we have a new rule that we're going to talk about is the power rule of exponents. And that's right here on page 70. Okay, power rule for exponents. Let a be a positive real number and n and m be any real number. Then we have a to the n raised up to the m equals a to the n times m. So the same thing up here that happened if I did 2 to the 3 plus 3 there, that's really the same as multiplying the 3 times 2 is what happens, right? Because that's the same as, let's just do it out here, 2 cubed squared, and multiplying 3 times 2 to get 2 to the 6th. So instead of doing this repeated addition, because that's what multiplication is, I'm just multiplying. I have 3 2 times. So it works out nicely. And it's much shorter and efficient, so less chance for error. So let's look at this example 6.6. We have a cubed b squared all raised to the second power. So we could do it the long way, especially if you're first learning and you're not sure. You could do, okay, that would be 2 factors of a cubed b squared. And I would get a to the 6th, b to the 4th. But instead of doing that, I could just multiply out. I could do a cubed squared, b squared squared, and then that would be a to the 6th, b to the 4th. Now you do need to watch for a couple things here. I really want to make sure that we raise each one, right? Because this is in parentheses there. So we need to raise the a cubed, and we also need to raise the b squared to the second power. It's pretty common mistake when people, just kind of skip that. They would just do a cubed. They might write a cubed b to the 4th, but that's not true. You can always double check it by doing it the long way. That's why I want you to see what's happening. It's really, 2 factors of a cubed and 2 factors of b squared, not just one or the other. So be real careful with that. So that leads us to this rule here, power of a product rule. And if we have ab all squared, to the nth, could be any power, equals a to the n times, that should say b to the n. So fix that. There's a typo there. So make sure you fix typo. Okay. Now here's a little warning for you. It's important to be careful only to use the power of a product rule with multiplication inside parentheses. This property does not work. It's not allowed for addition or subtraction. We can't just distribute that, so to speak. What this would actually be written as in a correct manner, we'll write it over here. What it would have to be is a plus b it's all to the m. So say, for example, I'll just write it out here. A plus b times a plus b dot 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 m times. You would just keep going till you had m factors. So for example, if you had a plus b squared, you would write a plus b times a plus b. And we'll do that a little bit later. But I just want to make a note of what, the common mistake is for that, is to just kind of tack on that square, but it's not a true thing to do. Example 6.7 is kind of a similar thing. This is the quotient to power. So if we have this a over b, I could do it the long way. I would have 3 factors of a over b. And that would equal a cubed over b cubed once I condense it down. So I think you get the idea that we can just raise each of the numerator and the denominator up to the 3rd power. So here's our rule, power of a quotient rule. Okay, remember that a and b are positive real numbers, so that takes care of our not having a 0 involved in a denominator. So now here's some examples. We're going to look at all the different power rules and cover them. So if we have 5, a to the 4th, b, all in parentheses, all cubed. Again, you can write out the long way if you want to make sure. But I'm just going to take each of these bases. So 5, that's like 5 to the 1. So 5 to the 1 cubed would be 5 cubed. A to the 4th cubed. So I'm going to actually write this out separately, what I'm doing. A to the 4th cubed, and then b to the 1 cubed. This was basically 5 to the 1 cubed. We don't write final answers having the 1 there, but I think it's really helpful for students, especially at first, to be putting the 1 in there, because a lot of times I'll see that left off. They'll just assume that's kind of like a 0, that they don't add it in. So be careful of that. And then we're just going to simplify. So we would have 5 cubed. A to the 4th cubed would be a to the 12th, and then b to the 1st cubed would be b cubed. And we can do our 5 cubed if we were asked to, so that would be 125, a 12, b to the cube, or 3rd. Now, finally, secondly, we have b. I guess I'm ready to be done. Sorry. You probably are too. So here we have our 5 squared. We have m cubed squared. We have 9 squared and n to the 4th squared. So now that'll simplify to 5 squared is 25. M cubed squared would be m to the 6th. Don't forget that I'm multiplying those because I have 2 sets of m cubes. And then I have 81 over n, or times n to the 8th. And that would be it for that one. If you could reduce the coefficients, you would, but these you can't. So now for C, maybe you want to try that one on your own and do it as classwork. So you could go ahead and attempt that. Pause the video. Okay, so hopefully that went well for you. We have x cubed squared, y to the 4th, all divided by xy all cubed. So that will simplify to x to the 6th, y to the 4th in the numerator. In the denominator, we have x cubed, y cubed. But we can go further because now we can apply our quotient rule. So I'm just going to look at the x values first, right here. And I would have x to the 6 minus 3. Now I'm breaking these down a lot. You don't necessarily need to do that, but, and then I have y to the 4 minus 3. Just want you to be able to see exactly, you know, how it lays out, especially if you were just looking back at notes. X cubed y to the first, so we don't write the 1 in, just leave it like that. So that's our final answer on that one. Okay, so now we're going to have example 6.9. We're going to look at 0 as an exponent for both classes, 95 and 97. And then for 97, you'll move on to another video that will cover negative exponents. So let's look at 0 exponent, or 0 as an exponent, and how that works. So if we have a cubed over a cubed, that actually equals 1. So let's write that out. I'm going to do a little proof here. And then if I have, because anything over itself is 1, right? You know that, right? So then I have my exponent rule that tells me, the quotient rule, a to the 3 minus 3 is how I can write that exponential also. And we still equals 1 on the left hand side. That's just always just going to carry down. That's how we do proofs. And then 3 minus 3 would be a to the 0. So then I can say, well, 1 equals a to the 0, and vice versa, a to the 0 always equals 1. So any number raised to the 0 power equals 1. And we can even do this little symbol here and write QED because we did a little proof. And you can write quad erat demonstratum. And that means that which was to be demonstrated in Greek. Actually, Latin would be that one. So that is a little proof that will be very useful. Okay. Remember, we have to have a being a positive real number. So let's look at a couple examples. 6.10. Apply the 0 power rule for exponents to simplify the following expressions. So if I look at this, I see 5x cubed y z to the 5th, all raised to 0 power. Well, it looks like, oh, do I have to separate that all out? I could go 5 to the 0, x, cubed to the 0, so on and so forth. But what this tells me is this entire thing is my base. So any base to the 0 just equals 1. So that is my answer. Now on part B, I need to look a little more carefully because it's not all just raised to the 0. I have things separated out. So I would have 3x squared, y to the 0 is 1, times 5 times x to the 0 is 1, and then I have a y to the 4th. Okay, I'm just going to put these all in parentheses. Then I would have 3 times 5 is 15. My x just stays, it's my only x value now because the other one turned to 1, and y to the 4th. That's really all there is to it for that. And negative exponents will be later for Math 97, but I can show you for Math 95 just how it kind of lays out. If you ever have to do something like this, maybe with scientific notation, it might be helpful. So you would have a cubed. That would be the same as having using our exponent law, and we would have a to the 3 minus 5, which would be equal to a to the negative 2. So that is how the right hand side works out. I could think of it this way. If I had a times a times a, over a times a times a times a times a, then I would end up with 1 over a squared. So that's kind of interesting how that lays out. So these two things are equivalent. So you can really do that with any exponent. And you would have the following negative exponent rules. A to the negative n equals 1 over a to the n. 1 over a to the negative n equals a to the n. And then if you have a fraction raised to a negative, it's the reciprocal raised to the power. So those are our rules there for negatives. Again, 97, we're going to work a lot more in depth, so watch the next video as well. Have a great day.